Yeah. दो बच्चों को बेटा
What happened? Who is not feeling well? Huh?
I was not.
You were not feeling well, but now you are feeling well. You're feeling better?
Yes.
What have you done last
Last time, how was your test in school?
Nice.
You did well?
Yeah, it was very easy. First, sorry, second chapter.
This second chapter, this chapter. You can't test on this chapter.
And now what?
We are doing this chapter only. There were
And
two
what you thought you
I was discussing about quality. Show me what we have to
This
discuss.
one. Yeah.
Valmay, show me what you have done. Valmay, I'm talking to you. Show me what you have done. You missed last time.
Yes. Suspension.
This is
Yes, yes.
only collide.
Correct.
The recall.
Yes, collagen, that's what I was discussing.
Still asking them.
Because they have no created some portions. So that.
Our test.
I will be getting this is for a test. So what test did you have now? This Sunday you had any test from this?
Yes, English.
For science I'm asking you.
Science and physics.
Test done, no. You are asking test is there, no?
Is it over? I'm asking.
Chemistry not doing.
Not yet done, no?
First chapter also not.
First chapter you did not write?
Matter, motion, matter in our subject.
Must have done it. No, not yet done.
No, it was not there. When it is exam.
Yes, it will be there. We will
This
announce.
Sunday, English test is there.
Okay.
Test.
Okay.
No maths.
English.
In full this whole month,
July.
July month, test is not there. Only one test is there. On 2 date, which is English.
No test.
And when our exams comes, 50 marks, there will be a paper, no, in UT also, or not?
Yeah, they will have.
What will I do?
Your first chapter you missed, no?
Should I study for UP plus? Should I
The
study
two
for
students.
school stuff? Should I study? Should I do the school homework? Should I do school homework? Should I complete UT's?
So it's very confusing. Is it not going along with what you are doing in school?
Ma'am,
These chapters are not going along with what is being done in
no,
school.
ma'am. School is very in their own mind. Now they told that lesson is not done in history. History ma'am told. History ma'am takes English also, no? So she told that principal ma'am told that history 2 chapters are coming in this Saturday test. How can it be? Second chapter is going on. Chemistry is still like going with the school.
Yeah, that's usually we try to do whatever is being done in the school so that it is easy for the children. It should go parallelly, you know, that is basically what we are trying.
Like in my class, is still matter I was there for first.
Okay.
I mean, my school first chapter is
Yeah.
per exam. Per exam first chapter.
Okay, come on, let us start.
It's okay.
I think so.
Any idea Kaushik is coming or no?
No. He will come late. Yesterday, what happened? Meena ma'am told he told to Meena ma'am that I will come late because my school bus comes at 3:50.
Oh,
So that's why he told that I will come.
okay. So it's already informed. Chalo, let's start. Is everybody ready?
Yes.
Come on, let's start with your notebooks and textbooks and all that. If you are having a specifically, I ordered for a new textbook because I know there's a little small part of the chapter which has been deleted. Okay. So,
Physical one.
Abhishek, get ready with your notebook.
Physical and chemical.
We will do physical change and chemical change.
So, medium.
This is good, no? We get repeat the same thing. We get and the last class that we have, we get up an entire division, and I will give you a lot of written work today so that it is okay for you. We had any problem with your homework? Homework is basically, you know why we give homework? Not because we want to burden you with little bit of writing, but just for you to recollect whatever you want. And for here, you are having only once a week, no? So that's really not much, yes.
Because the school notes are also written, so that's why we are expected write notes or doing class. I mean, if it doesn't take significant.
Yes, really does not take much time because whatever little bit of homework we give, this is only for recollection, you know, what we need to recollect. Okay, what is the last thing that you have written in your notebook? Characteristics of suspensions. Characteristics of suspensions. Okay. So we have done suspensions also. Okay, so if you look at what we have done last time, and if you recollect. So what did we classify matter? Now we are not talking about matter in terms of physical changes, chemical changes. We are not talking about the physical state, etc. But basically, we are talking about what is matter, how does it actually. So we said that it consists of pure substances. Not pure. Okay, pure substance we can talk in terms of what are known as elements and compounds. Correct? And the other one we are talking about what are known as mixtures. Mixtures we have done a lot. What are the two types of mixtures? Very good. Yeah, you have already learned. So homogeneous and heterogeneous. Homogeneous and heterogeneous. Okay. What is an example of a homogeneous mixture? What is it called as?
Suspension.
Homogeneous example.
Yes.
Maybe sandalwood.
Lime water.
Obtained by group.
Basically, it is a solution. It is a solution. Homogeneous mixture is nothing but a solution. For example, salt solution, sugar solution. So this is basically nothing but a solution.
Saturated solution.
Okay. So when you are talking about a heterogeneous, what are the two types? Can you recollect?
Collider and suspension.
So these are colloids and suspensions. Okay, so we have seen these two in detail. We have finished what is meant and we have seen what is the characteristic of a colloid last time I have given you. You have it in your book or no? Yes. Colloids or everything is there. What is meant by suspension?
It is a heterogeneous mixture. Particles can be seen with naked
Yes.
eyes. Particles scatter beam of light.
I'm for collider and beer.
Colloid?
Yes. It is a heterogeneous mixture.
So
Particles
we
are
have
very
seen,
small.
yes, so colloid is a heterogeneous mixture. If you look at the chart itself, you will know many of the points. Colloid is a heterogeneous mixture. Particles are quite small as when compared to suspension, but it is slightly larger than that of a solution. We have also discussed last time about what is known as Tyndall effect. You don't remember?
I think it was
Okay, let's say the
beam of
beam
light.
of light. I showed you one slide also there. Okay, so you can see the beam of
Particles
light.
scatter when the
Yes,
light
when the light
passes
falls, when the light falls, all these particles they are capable of scattering light, and that is how you are able to see the color. Now we have also seen regarding the solution. What is solution made up of?
Solvent and solute.
Yes, very good. It is made up of a solvent and a solute. Now, if you have a solution, like for example, if you are having a beaker of salt solution, will the salt settle down? No. It will not. In this, you can see only in a suspension. That means to say suspension is unstable. If you
Not
get
in a
it,
fixed.
yes. So, and you see that the particles will begin to settle down after some time. So that is a
and this will happen in collider solution.
colloidal solution is a stable solution.
But
Particles
there
are
is salt water, the salt will not
Their
settle down.
particles are settled down, no?
so a colloid appears as if it is an homogeneous. In appearance, it is appearing as if it is homogeneous, but it is not. You must remember colloid is heterogeneous.
Homogeneous cannot be seen with the naked
Particles cannot be seen with the naked eye.
because they are very small.
Very small. Colloidal particles can you see with the naked eye? They are also very, very small. Okay. Can you separate out colloidal particles by passing through a filter paper?
Yeah. No. You can't
Because the
separate
particles are very
collider.
small. They can pass through the filter
But we
paper.
can see the particles settle down.
Well, that is in suspension.
Suspension, not a collider.
Suspension, you should always remember the example. For example, if I say sand and water,
Salt.
not salt, it is sand.
Salt to dissolve.
Salt will dissolve over there.
But you understand, don't get confused between sand and salt. This is salt, water, or sugar solution. Remember sugar. That is easy for you. Understood, no? So here, particles will not settle down, but then in suspension, the particles will settle down. Okay, so this you should be very clear. If you remember this chart, what is given in the last page of your textbook, this refer to the chart which is given in the last page. We have done it. I've given you this list of the textbook itself.
Mixture and compound.
Yeah, that is it. See, yes. Did you see? So the chart I have already given you. This part of it is all over. Today we are going to discuss about what are elements and compounds. Because these are mixtures, but now we are talking about a pure substance.
So we have completed the impure substance.
All we cannot call it as impure. We are talking about mixtures. In mixtures, it is possible for us because it's a mixture of 2 or 3 more substances which are present. But there are many substances which are pure. What does it mean that it is pure? For example, if you take any particular element and you break it down into smaller and smaller and smaller and smaller parts, what do you finally get? Elements.
Atom.
Okay, so you are getting atoms of a particular one. For example, if I am taking carbon, okay, carbon means example is coal. Okay, you are taking a small lump of coal and you are breaking it and breaking it. Finally, you come to small pieces. You may just get small pieces of carbon. So when you are analyzing these small pieces, what do they contain? What is the smallest piece? What is the smallest particle? It is still an atom of carbon. That is why they are calling it as a pure substance.
Because in my school, my teacher said make use of pure system and impure system and impure system mixture.
It is not exactly, we can't call it as something pure. Okay, the definition here is it's a mixture, it's an entirely different classification. So we have finished this part of it. In the last round, we are going to talk about pure substances. Okay. So here, what is it? The smallest particle. What is it called? It is an atom. Okay. Now here we have taken carbon. So what is this atom of? Atom is also of carbon. It cannot be of sulfur. It cannot be of iron. You understood now? So how do we define an element? An element consists of atoms of the same type. So even the smallest part of it still contains of the same element. Did you get it? Okay. So that basically is what is known as an element. Each of these elements in nature, there are about 92 of them, which is in the natural form. And many more of these elements are actually manufactured in the laboratory. Okay, 118 of them are present, and most of them are very radioactive. They have got a very short life, but 92 of them are pretty stable. Okay, so when we talk about an element, once again we have what is called a classification. We can talk in terms of metals, non-metals, yes, and the third one is what is called as metalloid. See how I've classified metalloid, I've kept it in the middle. Okay, that is not a mixture. It is not a mixture. It
That's
shows
the properties
properties.
of metals and non-metals.
Yes. It is showing properties of metals and non-metals. So what is a metalloid?
Silicon.
Metalloid is an element. What is a metal? Metal is also an element. What is a non-metal? Non-metal is also an element. So basically we are talking about classification of elements. Did you understand how we do it? What are elements classified as? Okay, elements can be classified as metals, metalloids, and non-metals. Is that okay? It is not a mixture. Is a metalloid a mixture?
No.
No. What is it?
So
What is it?
element.
It is an element. Understood now? What is salt solution?
Homogeneous substance.
What is salt solution? It is homogeneous mixture. Don't use the word substance. All of them are substances. So now we have to be very specific in using the words. Is it a mixture? Is it a compound? Is it an element? Well, these are the words that you should be careful of. Are you okay now? Do you understand? Okay. Let's try to understand by giving a few examples. Can you give me a think of an example of a metal?
Gold,
Yes. Gold,
silver,
silver, iron. What are these wires made of?
copper,
Copper. All of
Luster.
them are. Huh?
Luster.
No, I'm asking you examples. Luster is shine. They are apparent shine.
Sodium.
Sodium, potassium, these are two things. This is an exception because sodium and potassium are actually very, very soft. Okay. So now I'll rub out this part of it because we've already completed. Have you all taken down this part? Are you sure of this?
yes, sir.
It's there. It's there in your books. Please check it out once again. Nisha, you have done this, no? This table, mixtures. I've already given you.
Yes.
Ah,
I have it.
Element mixtures, compound, homogeneous.
Homogeneous, heterogeneous, I have.
Ah.
Yes. So now I am going to wrap this out. And we are going to discuss a little more regarding metals and non-metals. Okay, on this side and that. Okay. So when we talk about elements, we said that we can classify elements as metals, non-metals, and what?
Metalloids.
Metalloids. Okay, examples we have already seen, right? For example, we said it is gold, silver, okay, copper, iron, aluminium. All of them are examples of metals. What can you say about a metal? What stage are they? Are they solid, liquid? Okay. Can you think of any exception?
Gallium.
Yes, yes. Think of it. What is mercury?
Metal.
It is a metal. But it is what state?
Liquid state.
It is the exception because it is only a metal which can exist in temperature at room temperature. We should tell you that it is at room temperature. These two, we do have gallium and cesium also. But they are also exceptions because they can be present in the form of. So we can say first thing is most of them, of course. Point number one is most of them are solids. Why am I using the word most? Because there are exceptions. Okay, there are exceptions. Second thing, when we say that most of them are solid, obviously it is a solid state that we're talking about. And they are very hard. Okay. What is the most characteristic feature of a metal?
Shine.
Shine. Yes, it has got a luster. Okay. Most of them have a luster. That means it has got a shine. It may have a silvery shine. Some of them have a golden copper type because it has got a copper type of a shine. Okay. Next.
Electrical conductivity.
Very good. Yes, it is a very good conductor of heat and electricity. Correct? Okay. Can conduct heat and electricity. 1 minute. You just don't write it. I'll dictate to you. Okay, and then you write it down. Okay.
We can't write this.
Which one? This table you write. Table part of it, if you want, you write. This I will give it to you more in detail. Okay. Heat and electricity. So that is why we are using metals like, let us say, copper, aluminium, which are very, very good conductors of electricity. Can it be drawn into wires?
Yes, ma'am.
What is the characteristic feature called?
Ductility.
Very good.
Ductility, huh?
Yes. Ductility. Ductility means what? It can be drawn
It can
into
be like
drawn into
drawn to
wires.
wires or then aluminium foils and like that.
Yes. What foil? If you are talking about a foil, that means it can be beaten up into sheets. What is that called?
Manipulative.
Malleability. So we have got two things: ductility and malleability. Now these are two characteristic features.
But it was that one more thing that produces sound. Like when
Yes. This can be beaten into sheets. Yes. Sonorous.
sonorous.
Sonorous means what? It can give you a ringing sound. Okay. So these are the characteristic features of what? What are metals? Metals. What are metals?
Elements.
Elements. So remember, metals are elements. Okay. How many naturally formed elements are present? 92 of them. And some of them, of course, are all different other type of. What is the element classified into? Three
Metals,
things.
metalloids, non-metals.
Yes. Are you okay till now? Okay. Look at your book. Look at your textbook. We will first read elements and then we will talk about non-metals. We have discussed about metals, then we will discuss about non-metals also. You have a textbook with you? Everyone has? Okay. Which page are we in?
Elements, right?
Yes.
Ma'am, I think table 9.
Elements is on page number 9. Ready? Who will read? Ready? Okay.
Robert Boyle was the first. Ma'am, should I read what the?
Yeah, on the basis, yes, read it.
On the basis of the chemical composition, substances can be classified either as elements or compounds. Elements. Robert Boyle was the first scientist to use the term element in 1661. Antoine Laurent Lavoisier, 1743 to 1794, a French chemist, was the first to establish an experimentally useful definition of an element.
See the textbook. He's reading you to look at the textbook.
He defined an element as a basic form of matter that cannot be broken down into simpler substances by chemical reactions.
What is important here? How do
It
you
cannot be broken down.
Yes, the smallest part of it, okay, the smallest part of any element is still going to be an atom and it cannot be broken down any further. Okay, please underline that statement in your textbook. Mark it. Okay.
Elements can be normally divided into metals, non-metals, and metalloids. Metals usually show some or all of the following properties. They are luster, shine, they are silvery grey or golden yellow color, they conduct heat and electricity, they are ductile, can be drawn into wires, they are malleable, can be hammered into thin sheets, they are sonorous, make the ringing sound and hit. Examples of metals are gold, silver, copper, iron, sodium, potassium, etc. Mercury is the only metal that is liquid at room temperature.
Okay, we stop there, okay? I want to just tell you something about beating up into thin sheets. Okay, it is so thin that, like for example, gold plated. Some of these ornaments, because gold itself is very expensive, we make it as gold plated ornaments. Okay, you take some ornament which is made up of silver and you can create it with the gold. It can be that thing. And I don't know whether you have noticed that when you have those sweets and all, you have that silver thing. Kaju Katli especially. You have that silver. Oh, that is that thing.
In Kochi also gold.
Somewhere. Not
Is that
Yes.
very hard.
Silver.
That is very dear, but that's why they would put my sister in foil. Just to give you an idea that it can be beaten up into thin sheets. Okay. And last time I was telling you about they are ductile, which can be drawn into thin wires. Okay, thin wires. For example, you take a small 1 gram of gold, it can be drawn into such a big, long wire. I told you about how we make use of these thin wires for making wedding sarees and all. Those are very expensive. Why are they expensive? Because such type of gold wires are actually used. Are you okay with this now? So learners and what are the exceptions here? One exception, of course, we were talking about most of them are solid. Here I said the exception, you have to remember that it was mercury, okay, because that's mercury which is present in a liquid form, okay. The rest of them are more or less okay. Melting point and boiling point. Most of them have a very high melting and boiling point, except for sodium and potassium. They're very soft ones. They can be cut with a knife. It is that soft. Lithium, sodium, potassium. These three things are pretty soft. Okay. Now let us look at non-metals. Can you give me 1 or 2 examples? What is a non-metal?
Aluminium.
Hydrogen.
Non-metals could be
Hydrogen. Somebody said coal. Oxygen.
Plastic.
You said plastic. I'll write it down and then we'll discuss.
wood,
Wood. You said okay.
water.
Bromine. Now there are certain mistakes here. Look at wood, look at plastic. Let's see why it is not a non-metal. Correct, this is correct. Hydrogen, what is coal? Carbon. So instead of writing coal, we better write it as carbon. Okay, oxygen, bromine, etc. Okay, so
So
all
that's
of
kind
them.
of gases.
Which one?
Hydrogen.
Most of them, yeah. Okay, but bromine is a liquid.
Yes,
Bromine is a liquid at room temperature. Okay. So you immediately know that some of them are gases, some of them are liquids, and substances like carbon and all are solids. Very first point, what do you mean? Most of them are solid. But here you see in non-metals itself, there are all the 3 states we can actually find. Now coming back to wood. Why do you think I said wood is wrong?
maybe because it's not an element.
Definitely it's not an element. Plastic is also not an element. What is wood? From where you get wood?
Natural.
Correct. You get it from the plant, isn't it? Okay, let us say take a branch. Okay, what is the branch made of? Cells. What is the cell one made up of? Bio you would have learned, no? What is the cell? Cellulose, correct. Isn't it? So when you're talking about wood, it is nothing but dead material, which is an organic material that itself is made up of carbon, hydrogen, oxygen. So it's not an element. When we say it is an element, it should be only one element.
It's a compound.
Yes, yes. Okay, so definitely not. And not plastic. Plastic is
Made
definitely
up of many elements.
yes. It is actually a polymer. Okay, they are all polymers, PVC and things like that. These are polystyrene. So definitely you can say plastic and wood. You are not going to call it as
Water.
water. What is the formula for water?
It's two,
How many elements are there?
two.
That's a compound. It's not an element, it is a compound. You understand now? Okay, so right now we're studying only about the elements. Next we'll study about
Nitrogen could be also a compound.
nitrogen. Yes, nitrogen correct. Now all these things, did you notice hydrogen I have put it as H, oxygen, nitrogen. Is it present in nature like only H atom? How is it present?
It could be mixed with any other.
No, I'm asking about hydrogen gas, oxygen gas. How do we show? We show it as 2. Isn't it? What is the meaning of O2? What is the meaning of N2?
Two
Correct.
atoms.
2 atoms of oxygen have combined together. There is a molecule of oxygen. Okay? Did you get it? So what is this? These are all non-metals. Now we have already put up a chart for metals and we'll see whether it is right or what are the differences. First point we have already shown.
Mostly solid.
Mostly solid for
Exactly.
metals. Okay, for metals. For non-metals, it can be present in all the 3 stages. Okay, do they have luster? No.
Solid.
But some who we talk about may have a luster here. I've given you the example here
But
in the form of what?
diamond.
Very good. Carbon can exist in the form of diamond, and you know, diamond is very lustrous. Okay, so once again, we can say non-metals do not have luster, but exception is diamond. Heat. Are they good conductors of heat and electricity? Non-metals. Non-metals.
No.
No. Once again, there is an exception.
Ma'am, oxygen
Oxygen.
is a combustion.
It's
Acha,
not a
हाँ,
combustion, it just supports combustion.
Here I'm saying heat and electricity. Heat.
And electricity.
Does it conduct heat? No.
No.
Does something conduct electricity? See from here this list. Carbon in the form of graphite.
Ma'am, electrolysis, the process.
We use, graphite, which is a very good conductor of electricity. Is it ductile?
Nah.
No, ma'am.
Malleable? No. Solderless? No. Are you ready to write down the list?
Ma'am, what is then?
Tin. It is a metal. It is a metal. Okay. Tin, lead, all of them are metals. Are you able to?
Tin is actually alloy.
Which one?
Tin.
Tin is not an alloy. You can use tin to make any other alloy. Okay? So now from the textbook, now we are going to read the next part of it about non-metals.
No.
Yeah, read.
Non-metals usually shows
See in your textbook 71 ready?
shows
Ah.
shows some or all of the following properties. They display a variety of colors. They are poor conductors of heat and electricity. They are not lustrous, sonorous, or malleable. Example of non-metal are hydrogen, oxygen, iodine, carbon, coal, coke, bromine, fluorine, etc. Some elements have intermediate properties
No, when
between,
you are reading, don't discuss this.
between those of metals and non-metals. They are called metalloids. Example are boron, silicon, germanium.
Okay? Now in your notebook, come on. Let's write down. Okay? Everybody has taken down this chart. Okay? Now I'm asking you to write down, differentiate between metals and non-metals. Okay? So on one side we have already written down the points of metals. On one side we have written down the points for metals already. Okay? And on the other side we are going to be writing corresponding points. Okay? We cannot write anything else anywhere. Should be a corresponding point.
Ma'am, should we have brought the bill?
Yes, yes. When I say differentiate, it is always to be written in the column. You can just come on, like, approximate these and draw a line in between. Most of them are solids.
What Mg is?
Mercury. Mercury. That is the symbol for mercury. Most of them are solids. Exception will be, yeah, write down exceptions also. It's for you to remember. Exception will be mercury, which is a liquid at room temperature. Did you write that, Manmai? Next one.
Ma'am, so in non-metals it would be like most of them are non-metals.
Yes. So for non-metal, what will you write? Non-metals can be present in gaseous form, liquid form, or in solid form. In all the three states. Second point, they have luster.
Luster exception 9.
Yes.
Can you please repeat first?
First point, most of them are solids. Yeah, put it up, see. What have you written? Michelle, what have you written? First point is over.
Most solid.
Most of the metals are solid.
It's like solid. Solid.
Exception here you will write. For non-metals, they do not have luster. What is the exception here?
Carbon.
Carbon in the form of diamond. Yes.
And for conductivity, because
Ma'am, but
Right.
all metals have luster, right?
almost
Most.
Sodium and potassium will not have.
they kind of transparent.
It's not transparent. It's whitish yellow. It's whitish.
So in luster and metals, exception could be sodium.
Don't write here. Basically, we don't talk about, most of them have a nice luster. Mika, finished?
Third point.
What did we say? They are good conductors. Most of them are good conductors of heat and electricity. Most of them are good conductors.
Now, what would be the exception and ductility? Buttons.
Most are lead. Sodium, potassium. Once again, sodium, potassium, lithium will be, which cannot be drawn into wires, it cannot be.
And lead is used in batteries.
That is lead batteries. But as a compound, no?
That's what point. Ductility.
What did you refer? Ductility. Okay, metals are
I mean,
ductile.
non-metal what will
Third point.
non-metal.
For non-metals, you will say they do not conduct electricity. But exception is there. What is the exception for third point?
Graphite
Graphite.
in the form of carbon.
Carbon in the form of
Graphite.
Ma'am, we can directly like graphite. Right?
yes, you can write. Exception you can write graphite. Remember that graphite is also carbon, diamond is also carbon.
And for non-metals are present in all three states. Fourth point.
Malleability, that means it can be beaten into sheets.
Not the exception, right?
Exceptions. Except for those three things that I'm
Mercury,
constantly
gallium,
learning. Yeah.
sodium, potassium,
Those will be.
Sodium, potassium, I mean, I write aluminum, but in non-metals.
Naturally.
Ma'am, in non-metals, in the mysterious point, the exception of diamond.
Carbon, non-metal are not lustrous, okay, but diamond, because it is a normal key, you have to mention in there. Yeah.
What is the 4.2?
Fourth point, ductility you have written.
Exception.
Metals are ductile, that means it can be drawn into wires.
And
This will be point number 5. Okay, is that okay now?
now I wrote it over 6 points.
Ductility and malleability we usually mention it at the master point,
And non-metals are not a good predictor of heat or resistance.
except for graphite. Graphite is a very good conductor of electricity. In the next standard, you will also learn something more about carbon and carbon compounds, which is called as allotropes. Okay, all these are allotropes. Different physical forms of the same metal, of the same element.
And fifth one, what do we do?
It is not sonorous. Are we done? So types of pure substances. Okay. Now, if you look at your textbook, it's not there. It's not there. They are not sonorous. It's not. This right not.
And they are not ductile or malleable.
Non-sonorous, non-malleable, non-ductile.
Okay. More to learn. Look at your textbook. There's a little more information that they have given about metals and non-metals. Are we ready?
Yeah.
No, yeah.
Ma'am, all metals are ductile and malleable.
No exceptions.
Exceptions are there.
And
No, those
metallites
things.
are there.
Potassium and
Mercury is already present in the liquid states, obviously.
Metallite. Ma'am, can we change mercury into like solid state?
I think yes.
Remember
the first chapter?
It's at liquid,
At room
liquid
temperature.
state at only room temperature.
So if you want to change it into solid state,
You can decrease or increase the temperature.
Please.
Freezing.
Please pass it
Freeze
away.
you have to decrease it.
Ma'am, can we take a quiz for last chapter? Quiz for last chapter. Questions.
This is exactly I'm doing now. As I'm teaching you, I'm asking you various types of questions. So if you are alert in the class, you will know what type of questions. Okay. Hundreds of questions I keep on asking you, I'm prompting you how you have to write, all those things. You have to be very alert in class. Right? Okay, are we ready? Read the class that small box.
The number of elements known at present are more than 92 elements are naturally occurring and the rest are man-made.
Underline how many are naturally occurring. 92 of them.
Majority of the elements are solid. 11 elements are in gaseous state at room temperature. 2 elements are liquid at room temperature, mercury and bromine.
Now they are talking about elements. Mercury is a metal, bromine is a non-metal. So they're talking about all the elements here.
Next chapter.
Okay, so they're just talking about elements as an entire group. Next.
Elements radium and cesium becomes liquid at room temperature, slightly above room temperature 303 Kelvin.
How much is 303?
273 minus 303.
303 minus 273. How much is that? 303.
30 degrees Celsius.
But he gave the correct answer, right?
Ma'am, he was opening the rough page, I don't know.
Answer.
Okay, fine, we are done. So we are usually taking room temperature to be about 25 at about 30 degrees. It is present in the form of a liquid. Are we okay with that? So, okay, yeah, good. So now we have completed about elements, right?
Yes, ma'am.
Metals, non-metals, finish. Now what about this metalloids? What are metalloids?
Metalloids
Metalloids
are
Properties of
elements.
both metals.
Yeah.
Please mention it as a separate point you now mention.
Metalloids are element containing
That have both the properties of
They
metals
have
and
properties of, come on, right, I'll tell you. Metalloids are elements, element,
are elements.
element, no?
elephants.
हमारे पूरे elephants लिख रहा था.
Element.
Where did the elephants come from? Okay, elements having intermediate properties of are elements having intermediate properties between those of metals and non-metals.
Metalloids are element having intermediate properties.
Of metals and non-metals.
Now, what does intermediate
In
properties?
between, they have got some properties of metals. some
Metalloids are
properties of-
element having intermediate properties.
Come on, all of you
between
mark it
metals.
in your textbook. Here it is. Look here, the first one.
There's one small paragraph.
One small line there. Mark it now and write down the examples also. Write down the examples. Boron, silicon, and germanium.
Boron is boron.
Is it a metal? What are we writing now? Yeah. It comes in group number 13, okay? Aluminium, boron, silicon, of course, is in carbon. What are you doing now? Finish writing? What did you write?
लिखा. Ma'am, not this.
1 minute.
Metalloids are elements having.
Write down the examples. Finish?
Yes,
Finished? Okay, good.
ma'am.
Finish, everyone? Okay, now we are going to discuss about compounds. I'm going to rub this out now. Followed?
Germanium. Ma'am, compounds can be broken
The
down
substance of two or more elements.
Yes, you're right.
and it can be broken down.
We'll see whether it can be broken down or not. So basically now we are talking about compounds.
Compounds can be broken down.
Okay, the simplest thing for you to remember is water. What are the two elements which is present in
Hydrogen
water?
oxygen.
Two and
Okay, now let us see sodium chloride.
sodium and chloride.
Yes. What is the formula for sulfuric acid? You remember sulfuric acid?
Yes, ma'am, it's
SO2.
No? What is sulfuric acid? Last time I gave you, I told you to take it down also.
No.
Of course. What do you want to know?
NaCl.
H2SO4, yes.
H2SO4, that is sulfuric acid. How many elements are present? What are the type of elements?
1, 2, 3.
Hydrogen,
Two elements.
sodium. Is it sodium?
Sodium, sodium is
Sulfuric acid.
Is it sodium?
Sulfuric.
Sulfur.
sulfuric acid.
Sulfur.
I mean, this 3.
O is what?
Oxygen.
How many elements are there? There are 3 elements. But you will also notice that they are present in a different, okay, ratio. It's a definite proportion in this one. So you will always have 2 atoms of hydrogen, 1 atom of sulfur, and 4 atoms of oxygen, which is combined together in a fixed ratio. Only then it forms what is known as a compound. Okay, so what is a compound? Compound can be made up of 2 or more elements. Can it be present in any proportion? No.
No.
It has to be present in a fixed proportion.
And it can be. Like, there are 2 atoms of hydrogen and 4 atoms of oxygen.
That is how it makes sulfuric acid. Sulfuric acid will not have any other formula.
Okay.
One with
For
three and
example,
six.
if I am talking about water, if I collect water from river or if I collect water from the sea, I told you I discussed about this, I remember very well. Formula will be H2O only. Okay, but a river water may have more some other impurities. Sea water will have sodium chloride and other things. That's why it's salty. It may have more salts. Okay, but the composition of this particular compound will not change. Is that okay? Okay. So how have these two elements, for example, when I'm talking here, look at the board. So when I'm talking about a compound like water, okay, suppose I want water, obviously I have to have hydrogen and oxygen which are combined together. We will learn a little more about it when we start learning about balancing of equation. So this is a chemical change. You understand?
There is only one molecule of oxygen between the
One minute. Did you understand that this is an element? This is an element, okay? These two elements are present in the compound, and it is present in the fixed proportion. Now let's look at the properties of water. This is a liquid. Is this a liquid?
No, gases.
Both of them are gases. So physical properties are entirely different. Okay? Hydrogen is combustible. It catches fire. Oxygen, it supports combustion. What about water?
Extinguishes.
It extinguishes. Okay, so the properties are entirely different. Properties of a compound are entirely different as when compared to that of the elements. Have you followed? So how is a compound formed? It is formed by a chemical change. So this is where we talk about a chemical change. Did you understand?
So a compound is an entirely new substance made by two
The
or more
combination.
elements.
Yes, combination of different elements. Now you may wonder here, I've got two hydrogen, I've got only two hydrogen atoms here. Oxygen, there are two atoms, but here there's only one atom. Where did the other atom go? That is when we learn balance and equation. Did you understand? So this is not a balanced equation. So in order to balance it, I put a 2 there, I put a 2 there, and now it is a balanced equation. We learn a little more about how we have to balance this equation.
7, 8,
eight.
You must have learned a little bit about yeah, a little.
but I still couldn't understand that.
We will learn a little more in detail when we do the next coming few chapters. We will also learn about how to do the balancing of equation. Are you okay now?
Yes.
Yeah. Now let me ask you one question. Suppose I have ice, okay, and afterwards it becomes water.
Liquefaction.
Correct? Is this a chemical change or is it a physical change? Everybody knows it's a physical change because this is also H2O. This is also H2O.
Yes.
Correct? Is this a physical change or a chemical change?
Chemical change.
No talk. You missed out my question.
But you are that it is a solid as a chemical or physical change.
Okay, so you must pay attention in class. Don't talk in between. I don't have to warn you again and again. So if there's a new substance formed, then it is a chemical change. Is that okay here? Okay, now let me ask you something. Suppose we are having a fruit. A raw fruit is changing into a dry fruit. Is it a physical change?
Chemical. Ma'am, raw fruit, dry fruit.
अच्छा,
Since raw से right हो रहा है.
raw से right हो गया. Suppose you are taking raw mango on the tree after some time, after a couple of days, it becomes ripe.
So physical change.
It's a chemical change because that chemical, different type of chemical compounds which are formed. Sweetness is there. Okay, fructose is being formed. Change in color, change in texture. Okay, change in different type of compounds. So it's a chemical change that's happening. Okay, here. Okay. Come back again to this. Now with compounds. See here, compound ready?
Yes.
Okay. A compound is a substance, I want you to underline this, composed of two or more elements, chemically combined. Did you notice that word? It is chemically combined with one another in a fixed proportion. Did you get it? So I'll make you write down that once again. Write it now, right? Please, let it be. Otherwise, I'll have to give it to you for homework. Better complete it now.
And we were studying that.
I didn't think. Little bit, I think, because it's for 1 week. No, I'll be meeting you only after 1 week. Come on, right? Compound, right? Everybody like this. A compound is a substance composed of 2 or more elements.
A compound is a substance composed of.
Textbook में दिया है.
You don't have a textbook, is it?
Yeah.
It's there in everything. In the handbook also it's there. It's there in the textbook also. Okay, chemically combined with one another in a fixed proportion. I want you to write down the formulas of a few things that I've already written there. H2O. Yeah, what is H2O?
Water.
And what is NaCl?
So salt.
Sodium chloride. Yes, it's a salt. It's common salt. Write down now. So NaCl is common salt. What is H2SO4?
Sulfuric acid.
Sulfuric acid.
Now you don't
Write down
forget.
this
Yes, you should write down because I want you to start learning now.
H2O water.
Finished? Okay. Now I'm going to talk about something else. There's a small activity and I want you to understand what's happening. Suppose I take, okay, A and B. Suppose I'm having a China dish and I'm taking iron and sulfur. Okay. I'm having a mixture of both of them. Can you separate it out?
Yeah.
Iron and sulfur. Yes, ma'am. No, ma'am.
Yeah.
Yes, ma'am. FES.
How do you separate it out?
Magnet.
By
Magnet.
you use the magnet, you're using the magnetism of iron to separate it out. But suppose you take the same thing in a test tube. Okay, now I've taken what? I've taken the two things. I've taken iron and sulfur and I'm heating it up with the help of a flame.
Chemical.
Yes, it's a chemical change.
Now it won't like be separated.
It is a new substance which is
Yes,
formed.
ma'am.
Iron sulfide. It's a new substance formed. It's a chemical change. Can you separate out iron from here? By
Yes,
using a magnet. Did you understand?
Is there any other way that we can separate it?
I think possible. Not by using simple substances. Maybe by certain type of chemical, other chemical processes may be used. That's quite possible.
Just like an example of chemical like iron and sulfur would be
This is nothing. This is just a mixture. But here, what have we found?
heating up
A
and
new-
forming
a new
substance.
Compound. This is a
A
new
new
compound. This is a compound. This is a
Element.
mixture of two elements. Are you clear about these things? Okay, clear? Okay, fine. So if you look at this activity which is given in your textbooks, activity 2.4, please look into that.
2.4.2.
2.4, yes. Below that activity 2.4, group 1, group 2, crush and put and all that, that is exactly what I have described here. Did you see that? Iron and sulfur mixture can be separated, but you cannot separate them. Okay, now there are a couple of questions which are given here.
Where?
Up to page 19.
90. And
There are some questions there. Did you see?
yes, ma'am.
Classify the following as chemical or physical changes. Cutting of tree,
Physical change.
Physical.
No new substances.
Chemical.
no new substance. No new substances.
Physical, no?
Physical.
Ma'am, I
Physical.
understand.
Yeah, correct. Melting of butter.
Physical change.
Physical.
Unless suppose you really heat up butter and then it
It's
starts
kind of
fuming, yeah, then of course. Okay, we'll continue with this next time. Next class, I will wind up this lesson.
Now, why don't you give these as homework?
Do it for homework. Do these questions for homework. You want?
Yes, ma'am.
Which one?
Ma'am, this first and two homework. Ma'am, my
And we are at it.
Next time, both of you are going to sit in different benches. I'm going to put both of you here.
Ma'am, they both are more than us.
Yes, ma'am. Children talking to you.
Thank you, class. Thank you. Please stand.
Thank you.
You will see this. Sit. What class you have now?
Maths.